Hi friends in my class, friends from our school, teachers, parents, students. I created these videos during the quarantine but realized that they could help other children and they can help me in the future with homework help and things like that. Parents, I know we learned math a long time ago and we learned it a lot different than we learned today, so hopefully this is helping you help your kids at home. Please like, subscribe, and share. To me, I want to make sure as many students are learning during this time as possible. Doesn't matter if they're not my own. I'm reviewing all of the things that we've learned this year just to remind people, so hopefully it's helpful to you at home. So today's topic is changing an improper fraction to a mixed number. This is a difficult concept all the time. We want to use visual help and we want to think about what's actually happening when we have an improper fraction in order to help us understand. So let's get started. So when you are calculating and you get an answer when you're adding or multiplying fractions, sometimes you end up with an improper fraction and it looks funky. So let's think about 8/3. All right, the meaning of an improper fraction is we have our numerator is greater than our denominator, and that means that you have more than one whole. So whenever the numerator is greater than the denominator, you have a fraction greater than a whole. Sometimes greater than 2 wholes, 3 wholes, you know what I mean. But this is greater than one whole. So the first thing that I need students to understand is what is a whole. And it's always different. That's a bummer with fractions. So what we need to think about is the denominator down. They both start with D, so that's how I help kids remember, denominator down. We want to think about the denominator. So here's a whole when we're thinking about thirds. This is the whole thing, and I've split it into thirds. Let's pretend it's a pizza. So I have a pizza, a whole pizza, I split it into 3. How many thirds do I eat if I'm eating the whole thing? 1/3, 2/3, 3/3, and written like this. So when I eat a whole pizza, when I'm talking about thirds, it's 3/3. What I want for you to recognize is that the numerator and the denominator are the same exact number. When the numerator and the denominator are the same, you have one whole, okay? So that's what's going on here. So 3/3 is the same as one whole, but right now I have 8/3. So I'm gonna show this with the area model. I'm gonna write down what's going on. So far, I've shown 3/3, but I need to do 8/3. So let me do another 3/3. What we've shown so far is 3/3 plus 3/3, which is 6/3. And what students should be thinking about now is how many thirds are still left. So this is called decomposing the fraction over here. And we're splitting this into as many wholes as we can. 3/3 plus 3/3. Sorry for the horn, I live in the city, if you can hear that. And you are left over with 2 more thirds. Nope, those don't look like great thirds, sorry about that. So let's make sure we have the 8/3. 3/3 plus 3/3 plus 2/3. 3 plus 3 is 6/3 plus 2 more thirds is 8/3. So where does the mixed number come in? Well, we think about how many wholes we have. We have one whole. See, the numerator and denominator are the same. Plus another whole. Numerator and denominator are the same. And then we have 2/3 left over. And that is the same as 2 and 2/3. So what did we do? First, I represented with an area model a whole so that we could understand what a whole was. I decomposed the fraction. I split it into wholes. I have 3/3 plus 3/3 plus 2/3. So I see the 2 wholes and the 2/3 left over. You can see it in the representation. 2 wholes and 2/3 left over. Okay, I want to do it with another denominator to make sure everybody definitely gets it. So let's give that a try. All right, let's think about something that's easy to draw for Miss Connolly. Let's do 17/4. Okay? Now, we dealt with thirds last time. Now we're going to deal with fourths. So I have a pizza. I'm splitting it into 4 pieces, into fourths. And how much am I going to eat if I eat the whole thing? I'm going to eat 1/4, 2/4, 3/4, 4/4. So, same as before, you should be noticing that when we make a whole, the numerator and denominator are the same. 4/4 is the same as 1 whole. So, while we're making improper fractions, some of us might start relying on multiplication, which is our goal, multiplication, division to make the mixed numbers, but we need to understand what's going on. So far we have 4/4. And some of you might be able to predict how many groups of 4/4 go into 17. We might have some left over though. But I'm going to keep drawing it for friends who are still learning, which is fine. We all learn at different paces. So far I have 4/4 plus 4/4, which is 8/4. Does everyone see the 2 holes here? And I have 2 holes so far here. I'm going to keep going. So 8/4, 9/4, 10/4, 11/4, 12/4. I'm going to label that I have another group here. Then I'll just go over here because there's space. You probably have more space than me, so on your paper, please do it in an organized way. So we're at 12/4, 13/4, 15. No, wait. 13, 14, 15, 16/4. So far I've made 1 hole, 2 holes, 3 holes, 4 holes. We see that here when we're decomposing the fraction, breaking it up to see what we can add together to equal 17/4. So we have 4/4, 4/4, 4/4, 4/4. That's 4 holes. But we still have 1 more fourth that we have to think about. So from the picture, the representation, you see 1, 2, 3, 4 holes, and you see the 1/4 left over. In decomposing of the fractions, when we think about taking out groups of 4/4, we have 1, 2, 3, 4, and a fourth. So this is what it looks like, 1, 2, 3, 4, plus a fourth, which means that 17/4 is the same as 4 and 1/4. Okay? So that's the understanding behind changing an improper fraction into a mixed number. This is our mixed number, a whole number and a fraction, making it one number, 4 and 1/4. That's why it's called a mixed number. This is our improper fraction here. Okay? So, how are some students able to do this quickly without the representation? If you're not, you still use the representation. It's no big deal. The understanding behind the representation and the decomposing of fractions is really important. But sometimes we want to think about fractions as division, which they are. So let's pretend that we have 16/5. Okay? What I want for you to understand is that the fraction bar, this thing here, I'm calling the fraction bar, what you write every time you write a fraction, the fraction bar represents division. So another way to think about this, don't lie to me. Another way to think about this is, watch me, 16 divided by 5. 16 divided by 5. 16 divided by 5. Okay? So some kids might be thinking, how many groups of that 5/5 can I fit in here? And that's how instead of drawing the representation, they're thinking about it. So some students might start thinking, well, I know that 5 times 3 is 15. So if I do 15/5, I get 3 holes because 5/5 plus 5/5 plus 5/5 makes 3 holes. And then they're saying, this is another way to decompose this fraction. It doesn't just have to be by 1 whole at a time or holes at all. We'll get into that another day. But 16/5 is the same as 15/5 plus 1 more fifth. Do we see the 16/5 here? So some students are able to see that 5 goes into 16 3 whole times and 1/5 left over. Okay, so that is how some students are getting there a little quicker. Let's look at that. Let's look at one more example here. And I just want to go a little bit over a whole because sometimes that can trip kids up a little bit. So let's think about 9/7. So same thing I was saying is the fraction bar represents division. 9 divided by 7. So students might be asking themselves, how many times does 7 go into 9? Well, I know 7 times 1 is 9. So that's 1 whole. And then I'm asking myself, how many 7s are left over? How can I decompose this fraction? And this is happening up in their heads. That's why they're not drawing all the pictures and everything. And they might see that they have 2 7s left over. So when you are thinking about changing an improper fraction to a mixed number, you can draw your visual representations, an area model, and it's really important that you know when the numerator and denominator are the same, no matter what size pieces we're thinking about, the numerator and the denominator are the same, that equals 1 whole. 3/3, 4/4, 5/5, 6/6, 7/7, all 1 whole. Okay, so when the numerator and denominator are the same, you can decompose the fraction like we did at the beginning by the wholes and then decide what's left over, or you can think about fractions as division. Okay, so make sure you like, subscribe, and share. Let's get as many kids learning as possible. Improper fractions change into a mixed number. I hope you enjoy it. I hope it helps you with your multiplication of fractions and addition of fractions that you'll be working on, and addition of mixed numbers. Please change the improper fractions to a mixed number when you're writing your answers. They're both correct because they're equivalent, but I want you to practice this, okay? Have fun.